Okay, hello everyone. We had some great panels so far. We're going to talk about auditing applications in general, and specifically encrypted applications, or applications where you have encryption implemented into them. My name is Tom. I work at Fhenix. I'm from engineering. I'm a developer. Yeah, let's do some introductions.
Howdy, everyone. My name is Michael Llewellyn. I'm head of solutions architecture at OpenZeppelin. That means I do a lot of the technical partnerships and have in the past worked a lot with the security research team on managing all of our audits that have at times included cryptography, as well as a lot of smart contracts that we're known for.
Hello, everyone. I'm Pavel Shabarkin. I'm senior security engineer in Quantstamp. We auditing and helping projects to deliver the secure protocols and making the space safe. So very helpful that you having me here today. Thank you.
Yeah, great. Thank you, Pavel and Michael. So first of all, let's kind of make sure everyone's on the same page here, and start by let's kind of explain what a security audit is. Why do you need a security audit, and why is it important?
I guess I'll start with saying that this industry made the audit term very unique to its own. Usually when you talk about audit in the context of more traditional spaces, you are either talking about a financial audit or like a SOC 2 audit or something that's against a set of standards. We don't really have standards in this industry, so it is what you make it or what each firm defines it as. At OpenZeppelin, we define a smart contract audit, or usually we define it in the context of a smart contract, but we have exhaustively reviewed every line of code, usually with at least 2 pairs of eyes on each line of code, and we feel there's a strong confidence that we have caught all the bugs, although there's always a degree of failure that can occur. But we would say that basically very high confidence and exhaustive review of all lines of code involved.
Yeah, I would say security audit is a specific evaluation of code that was developed at specific period of time, at specific point of time, rather just when security is supposed to be more the part of development lifecycle. So I would extend, currently we're using the term security audit, and it's just like a specific review and evaluation of security of the code at specific point of time. So.
Okay, that's interesting. And Michael, you touched a bit about how so the term audit is kind of unique in the crypto space. So how are you dealing with this variety of every company kind of setting something different or tries to test different things?
I would say just trying to be very clear about our process and knowing what a lot of the competitors say. There's lots of competitors that say audit, some say security review, some say something else. So the definitions definitely differ, but we just try to be consistent with our clients. And I agree with what he just said. It also is a specific snapshot. So you also have to be clear that the security of a protocol in terms of the confidence you get from an audit report doesn't remain if the conditions under which the code operate change based on what it was assumed at the time of the audit, or if you introduce new changes to the code. So there is definitely a life cycle. If you want to kind of maintain full audit status, you have to get recurring audits of those upgrades or of those changes. So it's a persistent thing. And then when you get more expansive and say for example, people will ask for audits of a fork of a Geth node, and we'll tell them, well, there's no audit of Geth. No one's audited Geth. No one's read all the code and then put out a report saying it's fine, and it would only be good for as long as the next hard fork. So those are things that we might more collectively call secure reviews, or more broader scopes where we might still try to find bugs and give higher levels of confidence, but the ability to exhaustively review every line of code is difficult. Really, when we talk about audit, we usually mean smart contracts, and we usually mean that because the cost of failure in a smart contract when it's managing funds is very high, so you do want every line of code to be looked at versus some pieces of node infrastructure. It might be okay to skip the logging pieces, not maybe skip, but skim compared to looking at other components. And with encryption, there are a lot of potential failure cases, but it really depends on what sort of implementation.
And it's also about time, right? So if you develop a product, you just want to make sure that specific areas of the code is audited, which you think is important to review, because most of the time you don't have a time engineering resources to ship a product. Especially right now in a bull market, we see that, okay, everyone is trying to raise money, build a product, and ship it within the specific period of time. When they don't have time, and it can be a potential pitfall in the long term because they can't deliver the secure architecture, the secure design, and yeah, it's like I would say it would be great to have a security as part of all the life cycle. So companies would hire security teams, would participate in every PR review in the architectural solutions and choices. But from what we see right now, the security audits is used to get a stamp that we were audited at a specific point of time, then we change a lot of stuff and we show investors that we're ready to launch, but it doesn't necessarily mean that they're actually ready to launch. So yeah.
Yeah, to add to that, because I agree with everything you just said, basically,
Yeah.
ideally, the team's already done all the security checks possible to find every line of code, and we're just gut checking to make sure that's the case as a third party. But in a lot of cases, it's no, we're the ones doing the security review that should be done internally, and in that case, you usually find a lot of bugs and sometimes won't be ready to launch, even though the auditors will do their best in the limited time to get them there.
Yeah, and security is just like a risk minimization game, right? You can't guarantee a security. Even if you hire the best audit firms, it's still people who audit in, and they're trying to get familiar with the code, investigate it, review, but we have cases when it is audited by best tier audits protocols. It's gone through contest, bug bounty, but still there is bugs. And we basically trying to minimize the appearing of these bugs, but it's not guaranteed. There is always just a risk minimization scene. And I would say projects should consider strategies to minimize the risk with different approaches. It's not just about a one-time commitment, right? You should have security team on site. You should have external reviewers like security audits. You should have bug bounty. Maybe for some applications, the insurance is maybe also applicable. Threat intelligence like analytics. So with all of those tools, you minimizing the risk, but you're not guaranteeing. So yeah.
Yeah, I like your point about audits being as a tool for minimizing risk. And wanted to ask you, what are your takes on, especially when dealing with code that deals cryptography or encryption. And me as an engineer, I usually, we see there are tons of options, either in terms of the libraries you can use to gain the same goal basically, but you have tons of different libraries and also so many space to kind of configure different things, and you have to choose the correct, doing randomness correctly and doing all the parameters. So what I'm asking is basically, what do you think are the best practices to, or what do you need to consider when you're writing or incorporating encryption in your applications, and how difficult it is, or how it kind of changes the risk minimization, or how difficult it is to minimize risk in that area?
Yeah, I mean, I think it definitely comes down to okay, what is the application for this, and then does the team understand enough to implement it safely? There are times where if you're using a simple hashing algorithm, you're producing a hash, reading the docs, usually it's a pretty straightforward thing, but maybe you need to be salting it. It comes down to the use case. Are you trying to store a password hash securely? There's specific things you have to look out for there versus maybe using that same hashing algorithm for doing simple lookups where you're not as worried about leaking secrets. It comes down to the details usually. But I would say definitely going with the most secure library you can find that's widely used, where there's clear guides that come from the developers who built that library saying this is how we intend you to use it. So just understanding the threat model for what you're trying to build for. And what is your responsibility to make sure you use appropriately versus what's been abstracted away by whatever library you might be using to accomplish that. And ideally, sticking to like what are considered safe practices, especially if this is not your forte. Like if you're a cryptography engineer, then yeah, you can go and probably do some more interesting and creative things, maybe even optimize if you're really feeling confident. But I would say like just having a self-awareness of one's limitations and understanding the risks.
Yeah, having a threat model like on site is very important thing. So you just understand what risk you're accepting, right? And one of important parts, I would say, when you're choosing specific libraries, it could be crypto libraries or any other libraries, is who is developing that thing. Is if it's an open source and open source maintains libraries, who is actually contributors and maintainers. Right now, we're seeing very specific attacks like supply chain attacks when guys who, in particular for a long period of time, for years, trying to contribute to the project, to the library, and then in a span of a couple of years, they put in a backdoor or something like that. And when no one expects and usually trusts those guys, they execute an attack and like just draining protocols. So when you're choosing even open source libraries and software, you have to really consider and have this in mind when integrate, because when you integrate this to your protocol, because yes, you're using the external software that you might trust, but should you trust? But it's still part of your protocol. And if something happens to that piece of code, you're responsible for that because your users running your application, which is using part of that code. So.
Yeah, I mean, you'll have, like, agree with everything you just said, because like you'll have cases where like the library might have been secure at one point, but then the maintainers just, they got bored, they went off and did something else. And even if it was secure at the time, like, you know, there are hashing algorithms that used to be secure that aren't anymore as computation gets more complex or more powerful. And then like you'll have examples like MilkSad where like something that was like, I think it was in like the Mastering Bitcoin handbook by Andreas Antonopoulos, but it was like mentioned there. I think it was like Libet Crypto, something like that. Like they were using it for wallet key generation, and then like they realized the entropy was actually not very good, and like years later, you have keys that are suddenly getting exploited out of nowhere because they could generate the private key wholesale, and you're suddenly like, uh-oh, that's a lot of key rotations. Where is this being used? It was in BitPay, it was in a few others, and it's like, were those teams keeping up to date, and like, or were they just reading, you know, a textbook that they got off the shelf and said, I'll use this crypto library? Like, yeah. You've got to like really like dig into the dependency tree and see like, is this something that's like still safe to use today, even if it was 5 years ago?
And it's happened even to Polygon some time ago. Like one researcher discovered that they integrated a library that was tripping nipples, and it like. Hopefully it was discovered by White Hat, not by Black Hat. But when you integrate it, you should be aware what this thing is doing, how it works, not just blindly integrate it to your protocol and like trust it. And there is also a thing with open source libraries and code is that actually it's not that well funded as a real protocols, and most of the time real contributors at the end of the day, they don't really have time because they have a job that they're working on and that's paid off, but they willing to contribute to the market and trying to maintain the code, but it's still not enough. It's like less attention, less focus on those things. And I would say all like specific libraries that the big protocols and companies are using, it would be very good if they could take care, like, and help those contributors to deliver better software, because, yeah, it's like a Trojan horse that.
I mean, we've had like big projects where we're like, they're paying us to audit like the Solidity code or something related to like a DeFi protocol, but then like some cryptographic library that's also being used within that has never been audited, and everyone has been assuming for years that it's perfectly secure, and usually it is, or at least nothing bad's happened yet. But it's kind of interesting that you see a ton of money being poured into like smart contract and like L1 audits, but like the actual cryptographic libraries that they are using that underpins the entire security for the space have never received an audit. They might still have very good cryptographic researchers that have reviewed it and it's secure, but it's just interesting that like they're not getting that attention because they're not, you know, the thing that leads to a token launch, even if they're the thing that makes the whole thing work.
So to your point, guys, do you have like, can you give like any rules of thumb or like any recommendations to the developers here? What to choose? Like, do you choose a big, you know, reputable library that is open source or closed source is better, or do you roll your own crypto, or like what's your take on what to choose?
Yeah, as a summary and outcome of what we just discussed, I would say always do your own research and try to find what is applicable to you. Because what may work for one protocol would not work for another protocol. So always do your research.
Yeah, like I would say, like look at the dependency tree, look at the latest updates, like read through the GitHub issues. Like sometimes you'll find GitHub issues where it's like mentioning an entropy issue or something like that. And I've done this before when reviewing like mobile apps that were like using, I think it was like Flutter or something like that, and it had its own like method of doing secure storage on like devices, and it was like there were weird entropy issues where it's like, okay, it's usually not going to be a problem, but it's an edge case, and like only specific people implementing it in specific ways would run into it. But like you wouldn't know that reading the README or the docs, because you know it's usually these things don't have very clear guides. So like really, like you have, luckily with open source, you have a lot of open source intelligence you can gather. So maybe you should just think about it from the mentality of, I wanted to break someone's app that was using this crypto library, what would I try to learn? And then kind of reverse it from there and say, do I think this is still safe to implement? Do I feel comfortable about it? If you're, like we've had projects that come to us saying, hey, there's this third-party library out there that we're using. Can you include it in the audit, or can you include it in the scope to additionally review? Because yeah, maybe that team couldn't pay for the audit, but for us, like it's important enough to include. Because otherwise we will like be forced to, usually for time reasons or cost reasons, focus specifically on the code that you're presenting that you wrote, and we don't focus on dependencies, and we'll only raise things that, you know, if we have time, we'll look and we see things, we'll raise it. But that's one thing you could also do, is tell your security researchers or whoever's working on it to include that in the assessment, assuming that that time and cost is something you can justify. But I would say in a lot of cases it is, or at the very least, like, you know, sometimes you just know, like, yeah, that library's safe, it's been used by tons of people, it's fine, but it is scary how many times sometimes people make that assumption.
And you touched a very interesting point on the edge cases. Like, I feel I'm coming from Web 2 security background, and I feel like during the Web 2, people, like projects, they don't set that high threshold of security because most of the stuff is just hidden. And even if an attacker and bad actor wants to exploit an application, he needs to do a lot of reconnaissance and actually retrieve the information. It's not a trivial thing to do. And most of the stuff, they just know that there could be bugs, there could be critical issues, and they are aware about it, but there is way, way, way more code than in Web3. But they just like, okay, it's in a private network, and it's a private execution, and they're like, okay, we just acknowledge it. In Web3, when everything is public and is accessible, we should set way higher thresholds. It's not acceptable to be on the baseline because there could be issues, the edge case, which may drain your protocol just in one transaction. And basically, sometimes it's not even enough, 99.9% of high security threshold, but there could be a very sneaky vulnerability that can drain whole your protocol. So it includes to dependency checks, so like to the whole grail of like your code base, you need to check everything. So
Context matters.
yeah.
Yeah, definitely. So I guess we have like a minute and a half for some questions for the audience, if there are any. Any questions for our panelists? All right. So we're out of time. Thank you very much. It was very educating, very interesting.
Thank you for having us.
Thank you all for listening.
Thank you, guys.